First up is Mario. Take it away. You've got 6 minutes or you're out. You've got 1 minute left.
Can I have the mic? Is that okay? Thank you very much. I've got another mic.
I want my mic back.
Okay. Yeah. Everyone hear me? Yep. Okay, great. This is the vainest photo I could find of myself. So that's me, Mario Visick. I work for a company called Envato in Melbourne. It's great. You should speak to the lovely people around here. They're handing out free gifts. Over there, we have popcorn and pinball. It's lovely. But I'd like to talk to you today about some fun facts that I've recently learnt. Did you know the temperature of a typical lightning bolt is hotter than the surface of the sun? About 6 times hotter, in fact. Lightning hits the Earth on average 100 times per second. And each time it hits, it creates enough energy to power 50 homes for an entire day. If only we can harness that power. Thank you very much.
Awesome. We're now running back on time. Nigel, you're up. Take it away, Nigel.
How do I follow that?
You're not having my mic.
Awesome. Yes, okay. My name's Nigel, and I'm saying that drop-downs are easy, right? Whoa, I'm going too fast. Slow down. Okay, so all we need is a little bit of HTML like that, and we get a simple drop-down list. Cool. But what if we want it to be dynamic? So we might have a little table, and we do a little bit of code, and we end up with a, well, maybe there should have been a drop-down list there, but okay, we end up with a drop-down list. But what about if we want blanks in there when we have a new record? So we might add that little bit of code, and what if we want a default on new? So when we're creating something new, we get a default record, so we add a new field up the top here, and we add this bit of code. Okay, what if the item's archived and we don't want to show archived items? So we'd have an archived field, and we add this little bit of code. Okay, so what if we edit an item with an archived selection? So something that, an old record that we edit that used to have an archived item on it. So we used to have normal in our list, but we don't anymore. We'd need to throw this bit of code in. Okay, what if we need a custom order? So sometimes we don't always want to do it in alphabetical. So we need to add another field in, and we end up with this. Okay, and then we repeat it for each list that we might need. And then what about the show page? So we'd just do something like this generally, but if we didn't have any relationship set up, and we had a nil error, we'd get an error like that. So we have to go throw in tries. What about matching? So normally we'd have something like this, but would that be the same idea in production? Solutions. So there was light at the end of the tunnel here, guys. So instead of all this code, you could just do this. Or if you wanted checkboxes, you could just do that. And coming soon is checkboxes, so that you can actually do multi-relationships. It has view helpers, so instead of having to put the try name in there, you can actually just do that, and it will, if it's blank or nil, just display blank. And instead of having to do this as a big conditional matcher, it will automatically do that on the instance, so you can actually just find all the different selections on that particular one via. It also supports, if you actually do need to look up the records, it supports a singular or a pluralized lookup, so that if you say the single one, it will find that. So if we were looking up other things, we could find them through the plural. So in summary, one table for all your selections lists that you might have in your entire project. It adds blank automatically. It handles defaults, handles archives, orderings of lists, consistent IDs, and consistent matches. And all you have to do is add that. Thank you.
Oh, awesome. Thank you. Now we're so running to time we can keep fitting in more. Or you just get to listen to me. Yay. Next up we have Shamim. Yep.
Yeah. Hello, everyone. Yeah. No.
Yep.
Okay. My name is Shamim. I work at Ninefold. I'm actually very happy to be here, and I have a complaint. That's why I'm here, actually. Everywhere, nearly everywhere I've worked, and every source code that I've seen, there is always a pattern that really, really drives me crazy. I don't know why, but as developers, we don't usually put ourselves in the place of the person who's going to read our code after us. And it's very funny because I was usually that person who had to maintain other people's code, and I was like, and I had to really maintain people's code, the people who were really experienced and had like years of Ruby development. But then when I was taking a look at the code, it was like written for a very, very smart person. So I actually want everyone to take a moment and think about the next person that is going to maintain their code. So this is actually an example. So in this some service class, there's a project so there's this method current for app, and there's a, oh sure, I think so. Yeah, is it better? Better? So in this current for app method, there is a block. And then inside that block, there is an each method, and then there is another method, and this is, again, a custom method that's defined here, and it's using yield inside with some values that has to be passed to it. And then if you go take a look at this load balancer service class and take a look at this remove and add methods, then inside these, you have a block with some input, and you're sending this information to the block as well. So you're having a yield here, and then inside this method, again, you have another one that's calling yield inside again. So when I came to this code and I was reading this, it took me like an hour to figure out what it's actually doing. And I couldn't refactor it at the time, so I have to go back and then come back a week later. And again, it took me like 20 minutes just to figure out what it was doing. So the reason that actually I put this code here is to note that the person who wrote this code is a very experienced developer. He has years of experience in Ruby. And I cannot believe that we easily do these kind of things. We never think about the next person who is going to read our code or maintain the code. So that's actually what I wanted to say today, that just put yourself in the shoes of the next person and think that you're actually coding for a person that is not as smart as you or that is less smart as you. Thank you.
Yep. And next up we have Matt Connolly. Big round of applause, guys.
Hey everyone. My name's Matt. Just put in a little talk together about some new authorization thing that I put together in an app that we're working on. It's a simple app. You guys have probably seen something like this. You have Rails and Devise and CanCan for authentication and authorization. And we might have an example routes where you have something like some clients. Oops. Each client might have a project and also users, and they might have items. And the items have they belong to the clients, they belong to projects, and they belong to users. You might also see just a global list of items, and that would be scoped to your authorization. So when you put that together, you end up with, where'd it go? These blocks like this, where you define your authorization there, and that becomes a bit unwieldy to manage. They're all before filter blocks. They're all macros that create before filter blocks for you, and the interaction between them is not really obvious. It's quite difficult to maintain as you're adding more routes and then adding more actions within those routes and so on. So yeah, what I was playing with is basically being able to declare the authorization in a nested manner in the same way that we do with our routes. And the goal of that was to make it easier to debug, easier to refactor, and easier to reason about what's going on. So just quickly, we can turn that into something like this, where these authorized blocks here have a very close relationship to what you see in your routes. So clients has projects and items, and users has items, and then there's items and items, and our authorization looks exactly the same. So if we need to make some changes to how things are routed, how things are authorized in that same kind of way, then what we're doing in those two places is exactly the same place. Changes that I make in here only affect that route, only affect the routes that would land in that authorization. So in order to come up with this one, I just did a little bit of digging into how this load and authorize stuff works. And we'll just do a little whirlwind tour of inside CanCan for those who haven't been through the code to see how it all comes together. So first thing load and authorize does has some controller additions that basically add this before filter and pass through all of the arguments that are there. So what is this resource class? It's called CanCan controller resource most of the time, and we add a before filter that calls the load and authorize resource method on it, which is that one. Nice thing at the top of this class says the class is used internally, you don't need to call it directly, which is exactly what we're going to do today. So here at the top is the bit that adds the before filter, and the before filter is basically get this resource class. This is a class method for the controller for whatever resource we're talking about, whether it's clients, projects, items, and go and do it. So instead of, and then the method that it sends was the one that was passed through before, which is basically this one here, load and authorize resource, which then loads the resource and authorizes the resource. So it's not too hard to put that into something you do yourself, which is what I've done in these methods here. So load and authorize, basically what we do is the guts of it down here is this bit here where we do the same kind of thing. We create the CanCan resource controller, and then we call load resource on it, and then we call authorize resource on it. And then if we did get something, then we yield through to the block inside so that these blocks here only execute if that client was actually loaded. Similarly, this block here only executes if project was loaded. So, and when you load an authorized item, it automatically inherits the scope of through the project. Similarly, the project automatically inherits loading the project through the client. So it makes it a lot shorter to read than these long lines here where you have to keep adding conditions onto the end of them, where it's really not obvious it's not immediately obvious when you read it. You really have to stare at it and you can't see exactly what's going on. Another advantage is that because this is actual instance code in your controller, when something does go wrong and you get a access denied exception, you can see exactly which line of your code it was at where that happened. So when you're running all your tests, you can say, authorization failed right here. You know which resource failed, and you can start to figure out why. And yeah, just put it all together. The other little helper was an if present one, where it skips the authorize if the parameter's not there. So just to help you basically do the hierarchical version of shallow, so you can load the resource without nesting or with it. And yeah, just happy to sort of say that it's been really nice using this in practice, where I can basically look at my authorization and how the authorized objects are are authorized hierarchically in exactly the same way that we define them in our routes.
Cool. Awesome. Next up, we have Andrew Harvey. Come on down, Andrew.
So I wanted to talk to you a little bit about the hub. I've seen a lot of you using it on your phones. I'm really excited about that. By the way, my name's Andrew Harvey. I work for Ninefold. I'm their technical community manager. But one of the really interesting things about the hub is it's not a Rails app. And that kind of tweaks my interest straight away. But I wanted to talk a little bit about why we built the hub. Because we actually first built a conference hub for RubyConf over in Miami. And that was our first attempt, and it was a lot of fun. But we built it because we wanted to change the way that we actually sponsor conferences. We actually wanted to contribute to the conference in a real tangible way and be involved in it rather than just throwing cash at it. Throwing cash at conferences is also very good. We still do that, but we felt like we wanted to contribute something more. But this was version 1. This was what we did at Miami. It was interesting. You can recognize the live feed there. We did the session planner in a very different way, and we realized that had some issues. And so we went and we built version 2 for Sydney. And I think we did a lot better. It's a lot more responsive. And we're really proud of it. But that aside, I wanted to talk to you a little bit about how we built it. And it's powered by Middleman. How many of you guys have heard of Middleman? Cool. How many of you guys heard of Middleman because of Steve Ringo? Really? There's some back there. There we go. Steve Ringo, I think, is the biggest Middleman evangelist I've found, but I'm surprised he didn't tell any of you. But Middleman is it's a fantastic static site generator, and I've been talking to a couple of people about Middleman this week, and they asked me, well, have you tried Jekyll? And I never really got to Jekyll, but the really cool thing for me about Middleman is that you have a lot of the facilities that you have in a Rails app just without Rails, which is a great thing. So you have sprockets there to handle your Sass or your less or whatever you choose in that sense. You can have the asset pipeline style templates, so you can go from ERB, you can wrap your Markdown template in ERB, so you can have some of your Railsy or your helpers inside your Markdown template, or you can have Slim or Haml if you want. And that's been great. But really what's very powerful is its idea of a sitemap and actually being able to write a almost dynamic, static site. The secret is the sitemap. And the sitemap is really Middleman's way of letting you access all the content that you have. And traversing through that means that you can create lists of things. So if we go back and look at this, this is all driven off the sitemap. This is all driven off Markdown files using front matter to provide metadata. And then actually on the page for a talk or a speaker, that's where we have the body content of the talk or speaker. But let's have a look at some code, because I only have 5 minutes, and I just want to show you some tricks that we use. If you want to have a look at it, it's actually open source. But here's the first trick. If you're familiar with Middleman, then you might know a little bit about the sitemap. But the first thing that we do is we actually manipulate the sitemap. The reason we do that is because we want to add some functionality to different pieces or different kinds of content. So we go through and basically we use a selector which says if it's stored in the speakers directory, that's a speaker file, and that's going to have a set of behaviors, which is really handy because then instead of going and traversing through the metadata of something, you've actually got a bunch of convenience methods. So you actually have a model object, basically. This is almost like just model view, which is really kind of handy. The other thing that we did quite extensively was composing finders. So this looks very much like ARL syntax, where you have the where. So we go sitemap, where the day is today's name. So if the day is Friday, it'll pick up all of the talks, which are all at a flat structure, and shove them together. and then we'll create sessions out of those. And we'll pass that query down to sessions. So if you see that second snippet, you'll see we're actually composing this query. The query that you're talking to there is already scoped, so only Friday's talks, and we can say Friday at 2 p.m., and that gives us all of the talks, all 2 of the talks at Friday at 2. And all of this comes down to allowing us to keep our views really tidy. When I first started building the hub, I was doing chain calls down through the metadata hashes, and that was getting really nasty. And so that's why I built this stuff. And that's 5 minutes, and I should tell you it's open source. So you can go and hack in it, you can look at it, and hopefully learn some stuff and use Middleman for stuff instead of Rails because it's fun.
Awesome, and now next up we've got Bethany. The stage is yours. Big round of applause.
Hi, my name's Beth. I work for DS. I'm currently out at realestate.com. So, in a conscious decision to avoid monolithic software, REA has decided to try out writing services that are small and have a single focus. You've probably heard of the word microservices. So microservices are good because they help you break up your code into small, manageable chunks. They're easy to maintain, upgrade, replace, and refactor, and also reuse. But on the downside, we have an increased number of integration points. So does this mean we have to write 1 million integration tests? So we like integration tests because they give us confidence that all the parts in our system are going to work correctly together. But that's pretty much the only thing we like about integration tests. They're slow, they've got lots of setup, they're flaky. When they go wrong, it's really hard to work out where they've gone wrong. So is there an alternative? So some really smart guys at REA wrote a gem called Pact based on the concept of consumer-driven contracts. So I can see they're onto good things, so I've kind of jumped on the bandwagon here. So what we want to do is try and unit test an integration. So we break up our integration into 2 parts. We have the service consumer, which is the project that makes the request, and we're talking HTTP requests here. And then we have the service provider, which provides the HTTP response. So in our consumer code, we write our tests using a mock provider, just like WebMock. So at this stage, we know that our consumer code will behave correctly when it receives the responses that we think are going to come back. But at this stage, we don't actually know, and this is one of the fundamental problems of unit testing, we don't know that our stubbed object is actually going to respond in the way that we think it should. So the way Pact differs from WebMock is when we run the tests on the consumer side, we take those interactions and we write them to what we call a Pact file. And then we take that Pact file and pop into the provider code and we replay those interactions against the provider code. And then we check the responses that we get back and we compare them with the responses that we think we should get back and make sure they're the same. A feature called provider states allows us to set up things like fixtures on the provider so that we can test the same request and have different responses back to make sure that we can handle all the different variations like a 200 or a 404, an empty list or a null. So the great thing about testing with Pact, they're fast, they're reliable, there's low setup, they're much easier to debug. When things go wrong, you're only testing one moving part at a time. So it's much easier to locate the point of failure. You don't need extra infrastructure, you can just run this in your CI build. The other good thing is that you're not only testing with Pacts, you're developing with Pacts. So you start thinking about designing your API with the best way to consume the data, not what is the quickest way to get this data out of my database into a response. So some upcoming development they're working on with pacts. One of the things we've discovered is we care very little about the actual values in the pact, in the node. What we really care about is, at this particular key, is the value the type of thing that we think it should be? Is it a string? Is it an int? Does it match this particular regex? The other thing we're kind of thinking about is working on XML matching. At the moment, we're just doing JSON. So we've been using Pact for about a year at REA, and so far it's really working for us. We have some data flows on the project I'm currently working on that hit up to 4 microservices, and they have feeds and delayed job and triggers that run once a day. And if we had to integration test this in the traditional way, it would be horrific. So Pacts are really working for us. If you want to know more, those are the GitHub URLs. There's also a Pact JVM. So if you have a Ruby and JVM integration, there's an easy way to test that as well. And come and grab me if you want to know more afterwards.
And last but not least, Mr. Ryan Big. You don't need to clap. Go clap, go on.
I love you too, random stranger. Or possible friend. Who was that? Where did you go? It's Ringo. Good. Second on what? Okay, so today I'm here to talk to you about what CI server should you use. There you go. Not done yet. Hold on, what? You can't see anything. Please hold, we're experiencing technical difficulties. Your call is important to us. You are 1015th in the queue. There you go. What CI server should you use? You should probably use Travis. That's a good starting point when it comes to using CI servers. If you have a simple project and you just want to run it across multiple different versions of Ruby or different database systems, Travis is really, really good for that. And one of the main guys for Travis is here right now, and that's Josh. If you have any Travis questions, please don't come and ask me, ask Josh. There are some bad things about Travis though. So just like the news, I'm going to start with the bad things and then go with the good things. The bad thing is that we sometimes get randomly failing builds on Spree. So these 4 builds here, the 9, 4, 8, 7, and 8, and 9, and 10, they're all the same part of Spree. 3 of the builds are failing, and 1 of them is passing, just on different versions of Ruby and different database combinations. And this is really difficult for us to debug on Travis because we don't get access to the server to get that instance of the project so we can rerun the tests again. We just have to click the rebuild button and hope that it will fail again, and we just have to experiment with that. That's the end of all the bad stuff with Travis. There you go. The good stuff is that Josh is part of the Travis team, and Josh is awesome. And we love Josh. And another good thing about Travis is that the setup for Travis, if you just want to get your projects running on Travis, is you just have a travis.yaml in your project. You add a script like this. You push your code to GitHub, and you say on Travis, run my code, and it does that. That's really useful. And you can have more complex Travis YAMLs than that. You can have, this is Spree's Travis YAML, and you can run, like we set up XVFB, just this as like a virtual frame buffer kind of thing, and we run all the projects with Spree, so it works, and that's nice. It also has PR testing, so if someone submits a pull request to your project, it'll automatically run that against Travis. So that's really nice. It's one of my favorite features of Travis, to be honest. Then there's TeamCity, and we've switched to TeamCity from Spree, from Travis, because we were having those indeterminate build failures. And on TeamCity, we have our own architecture, and we can log into the server and rerun the builds and see what's failing. And we can keep rerunning, and keep running, so we can get to that point. The bad things about TeamCity, though, is that it has its terrible, terrible interface that requires a lot of clicking, like so much clicking. You haven't done this much clicking since you've played StarCraft. It also has a really expensive license. I think it's like $600 a year or something if you want to run more than 20 build configurations. So if you're willing to fork out that much money, go ahead and do that. Otherwise, you might want to look at Travis. Good things about TeamCity is that it has an open source license. So if you're an open source project, you just put your logo, put their logo on your README, and they'll give you an open source license. They've also asked you to write a blog post about them too. But other than that, it's a pretty loose license, so that's nice. It's also good because it's on your own architecture. So if you want to throw your little spare computer at it and put TeamCity on that with 8 gig of RAM or whatever and run that like a spare computer in your office and do that, all well and good. If you want to have a super monstrous EC2 instance thrown at it or several monstrous EC2 instances thrown at it, go ahead. It can support that. In Spree's experience, we've been experiencing builds running up to 3 times faster than on Travis. That's just in our experience. I just thought I'd chuck that anecdote in there at the end there. It's also solid as. So if a build's going to fail once, it's going to fail again and again and again. And if it's going to pass, it's going to pass again and again and again. And TeamCity has never once fallen over on us. Touch wood. So what CI service should you use? You should probably use Travis, but then also check out TeamCity. Thanks.